right? So imagine Joe runs that way east. Do you know which way is east? I just told you, I guess, but yeah. Did you tell me? Okay, you'd be surprised how many seventh graders in this hall, if I say go to the east wing, they'd say, which way is that? I wouldn't say go to the east wing, that would be funny to mess with them. But anyways, my point is seventh graders don't always know that. Anyway, Joe runs east forever. Cool. Mookie also runs east forever. What is the difference between their positions approach as time goes on? What's the distance between their two positions approach? As they run forever, isn't that some kind of Greek mythology story? They gotta walk forever or something? I'm sure it is. Or is that a movie? Oh, that's X-Men. Yeah. Yeah, X-Men said walk forever. Yeah. That lady with the power, the mental power. Yeah. Okay. So anyway, back to the calculus. I hope I'm recording this lesson. That's awesome. So they're both going that way forever. What is the difference between them approach? Zero. Okay, I heard zero. What else? Oh, okay. What else? Negative infinity. Okay. No, that's the right answer yet. 2. 2 is not it. 3, not 3. Okay, what? I think it depends on something. It depends how fast. Depends on how fast. That's the right answer. Okay. If Joe is running much faster, then the distance approach between them approaches infinity. If Mookie is running much faster, then I guess you could say the distance approach between them is approaching negative. But if they're running at the same rate, then the distance would stay the same as whatever it was to start with. Do you agree? So at the point I'm trying to make is the rate matters. And without that, you couldn't know. Now, that is the idea behind the first indeterminate form. What if you get a limit that yields huge minus huge? Now, first, let's now remember that infinity is not a number, and infinity minus infinity is not like 4 minus 4. It's more like democracy minus freedom. Okay, what's democracy minus freedom? Exactly. What does that mean? How do you know what that means? Okay, so infinity is a concept. It's not a number, and so you can't say it's 0. That's ridiculous. Instead, you need to get into it more. Infinity minus infinity is indeterminate, and that means we want to go at the rates at which they go to infinity, but we don't start using derivatives yet. All right, it tends to lead to mathematical failure. Instead, you want to make it a L'Hopital problem so that you can compare rates, but when I say compare rates, it needs to be in a ratio form. So when you get a case like this, you have to make it a L'Hopital kind of ratio form case, and then do L'Hopital. So say you looked at something like this. I don't even like that the way it is. I can't remember, quite frankly, what the graph of cosecant looks like. I guess I could do it. But do you mind if I just right away rewrite this as 1 over sine minus cosine over sine? Are you cool with that? Okay. Now, I'm not going to make you do that separate limit thing yet. Let's first see if this is even an indeterminate form. So, as x gets small positive, what is sine of x approach? 0 from the positive side, yeah? So is this huge positive, or 1 over small positive, or 1 over small negative? And so 1 over small positive is infinity, okay? Cosine approaches 1, and the bottom, again, approaches small positive. So that's 1 over small positive, and that approaches infinity. And so this is indeterminate form. Now, before we go to taking derivatives, you need to make it a quotient so that you can use L'Hopital. L'Hopital is only for quotients. So it's logical to rewrite this as something like 1 minus cosine over sine. Wait. All right, now we're going to do L'Hopital. If it was indeterminate before, it's still going to be indeterminate. It's not like getting a common denominator makes it So now I know the answer. So the limit as x goes to 0 of 1 minus cosine of x, that goes to 0. The limit as x goes to 0 of sine of x, that goes to 0. So you can see then by L'Hopital, this limit is equal or equivalent to the limit of the derivative quotient or ratio, which is sine of x over cosine of x. And that is, that's true tangent, but the limit is 0, yeah. Okay? Okay. This one I feel like they floated around and butchered it, so instead of saying you try it, we're gonna try it. Okay? All right. I can't, is that a 0 positive or 0 negative? Okay, cool. All right, so 1 over negative 1 plus cosine of x. I think we know that cosine goes to 1, and so that goes to 0. But it's kind of important to know, is it approaching 0 from the positive side or the negative side? Because I really need to know that, because that'll make a big difference between infinity or negative infinity. And that's important. So what about cosine? Is it a little more than 1 or a little less than 1? Yeah, cosine's never more than 1. Do you agree? Okay. So if this is a little less than 1, then is this small positive or small negative? Yeah, okay, so this is small negative. 1 over small negative minus 1 over small positive, because x is a positive small number. So this amounts to, what's 1 over small negative? Negative infinity. And what's 1 over small positive? It's minus a positive infinity. Now, is that, I don't know. Negative huge minus another huge number is that I don't know, or is that I know? Yeah, it's negative infinity. So this is not a L'Hopital case, and that is part of L'Hopital, is when do you use it and when don't you use it. And that is, to me, actually harder than L'Hopital, is to nail down those cases when you're not supposed to use it. You follow me? Okay, now, that said, I think you'll find the other one is indeterminate. When I change that to addition, now it's negative infinity plus infinity, which rearranged obviously is infinity minus infinity. So that is that indeterminate form. So would you then proceed on with the get a common denominator, check to verify it's L'Hopital, and then use L'Hopital. Oh, man. So you're getting undefined, yeah? Okay, I want you to pretend it's a multiple choice problem and tell me, is it infinity or negative infinity? If you're at the stage where you're getting undefined, you're doing well. I want you to go more and tell me what kind of asymptote we got going on, approaching infinity or approaching negative. And I hope I can answer this question myself. Let's see. So that's a little less, and that's not geez. Oh man, this is a freaking nightmare. Let's see. So I get -1 plus a small pot of plus one little less. So what are you feeling like that bottom is? Small negative or small positive? All right, let's think through this. This is hard. Okay, so -1 is -1. It is what it is. Cosine will contribute a number that's close to 1, but is it a little more or a little less? A little less. So would you agree that the fight between these two results in a negative small? Yeah? Okay. Now this is positive small. So that's a small number, but we're subtracting it. So I have negative small minus positive small. So isn't that still negative, even more negative small? So I'm getting 1 over negative small. So what would we conclude? Yeah, it's negative infinity. That is rough. I don't think you'll see any that are that hard on the homework. At least not in Saxon. I think I might have pulled that from a different book. I don't know. That's rough. Okay, are you with me? If that's freaks you out, don't worry. They won't be that hard. All right. Go to the back side. Another indeterminate form is, I think I made a correction in your notes. It says approaching infinity. Okay. Approaching infinity and approaching 0. Now, most books just don't use the little arrows. They just say indeterminate and form infinity times 0. Just so we're clear, I'm talking a form like this, sine of x log of x. All right, that's approaching infinity and approaching 0. It's not this here times whatever. That's let's see, 1 over x, maybe whatever. That's not indeterminate. Okay, I know exactly what that equals. What does it equal? It's 0. Okay, it's not approaching anything. It is 0. All right. So although the notation for this is commonly just infinity times 0, in your mind you have to remember it's approaching 0 and approaching infinity. Now you're talking huge numbers times small numbers. It could be negative infinity. That's fine. The big idea is approaching big and approaching small. Which one wins? Well, again, it depends on which one's doing its thing faster. Is the one going to infinity getting bigger faster than the one going to 0 is getting smaller? The rate matters, and just like before, if the rate matters, then we need to look at a comparison of the rates, and so we need to make it a quotient and use L'Hopital. First of all, those should be x's, not p's. I apologize. I don't know what I was thinking. But now, if I were to look at this, what does sine go to as x goes to 0? 0. And on the positive side, and what does log go to? Negative infinity. So I'm getting really small positives times really huge negatives. That kind of could be lots of things. So if that's the case, now we need to, it is an indeterminate form. We need to make it a quotient. So we can use L'Hopital. All right. So the question is, all right, I guess I got to put one of these in the denominator. That's weird, but okay. Which one is more logical to put in the denominator? I agree. I think the sine is log of x over cosecant of x. At least I have a way to write that. That's decent. All right. As x goes to 0, I'm doing L'Hopital here now. As x goes to 0, we said log goes to negative infinity. What about as x goes to 0, cosecant? Take 1 over sine if you like. 1 over sine would go to 1 over 0, which means 1 over small, which is Okay, so this is an indeterminate form. Infinity or negative infinity over infinity is a L'Hopital case. And so by L'Hopital, we could say this limit is equivalent to the limit as x goes to 0 of 1 over x over, what's the derivative of cosecant? Please tell me you remember that. Negative cosecant cotangent. That's a bit of a mess, so I'm going to take a cleanup step or two. I'm getting negative sine and tangent in the numerator and x in the denominator. Yeah? Oh, man. So isn't that 0 over 0 still? Ah, that stinks. Alrighty. Now then, the limit as x goes to 0 of negative sine of x tangent of x is 0. And the limit as x goes to 0 of x is 0. So, by L'Hopital again, this is equal to, I'm going to write here, but what is the product rule derivative of yield negative sine tangent? Negative sine secant squared minus tangent cosine. Yay? Sound cool? Over 1. That's at least good. The top. The sine makes the first go to 0. The tangent makes the second go to 0. So I'm getting 0 on the top, 1 on the bottom. My answer is 0. Okie dokie. That seems like the sine won. The sine outpaced the log. Are we cool? Try the next one on your own. And if you want to just start by writing as a quotient, I'm fine with that. And then look to see if it's indeterminate. You could definitely rewrite it first if you like. I guess we could kind of use end behavior, huh? Oh man. If I don't use end behavior, I'll probably need to do 3 L'Hopitals, right? Are you not seeing what I'm seeing? Oh. It certainly makes way more sense to put the e in the denominator because it's got a negative exponent, yeah? So surely the top goes to infinity, the bottom goes to infinity. And so by the book we could do L'Hopital, but let's just say by end behavior. Which one will win? E to the x. And so will this go to infinity, 0, or something in between? Let's just call it this way. You with me? All right. So what are the 2 indeterminate forms you learned today? Let me look at my nose. Come on. Product of infinity times 0 or infinity minus infinity. Those are indeterminate forms. Make it a quotient before you use L'Hopital. All right. Questions on you still have 89 or you just turned 89 in? Still have 89. All right, let's get 89 turned in. If you have 89, get it out. Let me know what you want to ask about. 11. Is 11 replaced or replaced?
Replaced.
7.
Oh wait, never mind.
It's not a book. All righty. Here we go. 11. 89. Oh my. Should I write some confusing notes on this or something? All right. All right, we're some kind of confusing notes for this. All right. So, I don't plan on a test, but I wouldn't object to a note quiz or a homework quiz this week. For example, can you tell me the differential equation for exponential growth? Okay. Ouch. Can you give me the verbal statement for exponential growth? The amount grows, okay, at a rate proportional to the amount. Yeah. All right. You need to get those in your brain. Okay. It, however, said start from the differential equation, find a particular solution. So they want you to do the integration, not just jump to the exponential equation. So I think they use B and P, but that's okay. So if I separate the variables and integrate, I get log of the absolute value of A equals KT plus C. Are you with me? Okay. They tell me, man, they don't really tell me two cases. What was I thinking? They don't give you two cases, do they? What was I getting? I don't know either. What is R? K represents what? Okay, so here we go. That's in a business textbook, that's the way this would be written. But R is the K, and K is the excellent circular logic. K, R is K, and K is the interest rate. Now, for the life of me, I can't remember, is that 0.08 or 8 or 1.08? What is it? It's 8, right?
Yeah.
It's not 0.08? Feels like that would grow like crazy. If you did e to the 8t, that's gonna grow really fast. I don't think it's 8. I think it's 0.08. Okay? That's gonna grow way. I mean, I would love that compound interest, but not if I was paying loans. So I feel more like balance is, let's bypass the Diffie Q. You're right, my explanations are terrible, sorry. But when you use this formula in a text, R represents the interest rate in a decimal point. So it should be 0.08t. Are we cool? Now, I know 0.08 is small, but it's still positive, so we're still going to grow. We're good. Now, I think the question is, how much would you have to start with to get 20,000 in 21 years? So I guess let's just focus on, your question might have been, what did you mean by your calculus notes? And they were bad, I apologize. But ignoring those and solving, wouldn't you agree that this means find when how the balance would reach 20,000 when the time is 21, and solving for P? Does that get you started? I apologize. My notes are terrible. Are we good? Okay, sorry. 7, sorry. Is 7 still a question? Yeah. Okay, 7. 7 is... Okay, suppose the average value is 3. Is there a number that makes the average value? If so, bless you, what is that number? All right, so let's first say f of x equals 3x squared on -1 to 2. They say the average value is 3. That's handy.
Sorry, I couldn't quite hear you. Could you please repeat what you said?
All right, sorry about that. -3x squared. So, really the question is, when they get that average value, does there have to be a point on the curve where that average value actually occurs? And yeah, the function is continuous really what they're saying is the MVT for integrals applies. And now the only question is, they're actually doing a lot of the work for you. They're just saying, all right, that average value of 3, what x makes it? So if f at c is 3c squared, then the x that makes it is, so plus or minus 1. Now this actually is a good question because I could not remember the actual theorem. What is it, interior or exterior? And I don't even care what Saxon says because he's not a math by the book theorem kind of person. So I'm going to use this is text. Question is -1 count or not? That's what I'm looking into. Give me a minute and I will answer that. I can't remember if it's inclusive or not. Integrals 421. Theorem for integrals. There is a real number inclusive. Inclusive. So, I don't know what the back of the book says, but it should be both. 1 and -1. Both satisfied. It's inclusive. Okay? All right. That's it. Any other questions I need to know? 10? 10? Okay. And 10 is a verbal interpretation problem. So you're trying to take the English into calculus. So when it says the slope at any given point is twice the x-coordinate, what did you make out of that? Y dx equals 2x, something like that, yeah? And in a differential equation sense, then, this is separable. So y is x squared plus c. If it passes through 1, 1, then that implies that c is 0. So the equation is just y equals x squared. I didn't think it would have mattered, but anyway. Okay, does that make sense? Okay. Alrighty then. That's it. Let me know if there's another one or one on tonight's you want to talk about. We're caught up. I can't believe it. Do-do-do. Do-do-do-do-do.